All right. Well, welcome everyone. Welcome to Backend. My name is Jason Maurer. I'm going to be your instructor for the next month and a half. Like I said earlier, it's good to see some familiar faces here from some of my previous cohorts. I'm really looking forward to getting to know the rest of you. So a quick bit about myself before we get started. I've been a developer for about 12 years. I taught myself when I was just a kid, actually writing HTML and CSS in Microsoft Word as my editor of choice. Believe it or not, there was no Lambda school back then to show me the ways. So it wasn't a glamorous start, but I eventually started to figure stuff out. I eventually moved on to writing LAMP stacks, which is PHP and MySQL and Apache. I did that for several years and also used a lot of jQuery and eventually Backbone when it first came out. If anybody here has ever heard of Backbone, it was actually one of the first full-on JavaScript frameworks, and it was like the coolest thing ever at the time that it came out. So after learning the basics, I somehow convinced this musical instrument inventor to hire me to build his website, which was my first big job as a freelance developer. The original website that I made over a decade ago is actually still live. I looked it up this morning. It's still live if you want to check it out in all of its magnificent glory. There it is. There's my first freelance job. He invented this this weird instrument that got used in the Matrix and a bunch of other random stuff. But anyways, since then, I've held several different jobs over the years, doing full stack development. I've worked at several companies, but I've spent the majority of my career just as a consultant and a freelancer. So if you have any questions about doing that type of work, I'm happy to talk more about it later. Most of my work during the day that I do, it consists of backends written in TypeScript, Go, Postgres, occasionally front ends in React, Elm, a few other frameworks. So I'm really excited to teach you about backend and Node and kind of show you some of the techniques that I use in my day-to-day. Not all of it matches up with the material in the training kit, so I apologize in advance for that. But I do think it's important to go off book at times and kind of show how some things are actually helpful and how some things are not. So yeah, let's get into it. So backend. So far, all the sites that you've built so far have focused mostly on looks, right? The creative side of web development. You've been working with layouts, colors, images, UX, piecing everything together into a really nice looking app, right? That's no longer the case, okay? We're now getting into the deeper engineering side of web development, which focuses more on how the data is organized and how we validate it and how it gets persisted, how we keep it secure, how we can deliver it to the client in performant ways. Building an app it's a lot like building a house, actually, when you think about it. When you're learning front end, you're essentially learning how to be interior designers, right? You're painting the walls, you're filling it up with furniture, you're making it homey, you're making it practical and comfortable to live in. But now that you're getting into back end, you're kind of learning how to set up the house's plumbing and the electrical systems and the security systems, the HVAC systems, right? You're essentially learning how to make it safe to live in. So unlike front end, a really good back end is actually going to go unnoticed by pretty much everyone most of the time. And that's because if a back end is working as it should, it's not going to run slowly. It's not going to hinder any front end integrations or anything like that. Just like how you don't really notice that your house's plumbing or your house's electrical system is there until it stops working, right? So that should be the goal of our backends that we build throughout this block. That should be our goal, is to essentially create these backends that are so reliable that it goes unnoticed by pretty much everyone, right? Just working its magic behind the scenes, so no one has to really worry about it, right? Which means as backend developers, we need to keep up to date with best practices. We need to write lots of tests. We need to learn how to keep up keep our data schemas clean and how to keep our data safe from hackers, and so on and so forth. So I want to preface this entire block just by saying that that backend is really so much more in depth than what we're able to cover in Lambda School. 6 weeks is really only enough time to skim the surface with an intro to some of the more important topics. So hopefully you'll take the initiative after we're done and delve deeper into backend if it's something that interests you. But keep that in mind, we're only skimming the surface of backend. There's a lot more that you can learn just on your own. Okay, and then just a quick reminder on the Slido. So make sure that if you have any questions, ask them in Slido instead of Slack. I probably won't answer a question if you ask it in Slack, just so it doesn't get lost. It helps to keep everything organized in Slido. And there's also a poll, a live poll in Slido that's just a 5-star rating as to how you're feeling about the content. We just update that periodically as we go through so I can kind of get a feel for how everyone's feeling. All right. So we keep throwing around these terms, right? The front end, the back end. We all know what the front end is, hopefully by now. You know, it's a collection of HTML, CSS, and JavaScript code that runs in the browser to essentially just display a user interface, right? That's our front end. But how would you explain the back end? Let me post that as a question in Slack. How would you explain the back end? Answer in that thread. Now that we've had a chance to talk about it really quick. Magic. Good to see you again, Yasir, by the way. What is the back end? Good. Bases on which your app can scale, hidden, it's the server, it's the architecture, the place where the data is held. Tubes talking to each other, I like that one. Good. Yeah, so essentially when we're talking about the back end, right, when we think about what the back end really is, it's essentially just a computer program, right, or a collection of programs that runs without a user interface, usually, that's set up to accomplish a myriad of different tasks, right? Things like responding to HTTP requests, or maybe sending out emails, or scanning a system for viruses, or writing data to a file system or a database, or converting an audio or a video file, right? These are all tasks that a backend could handle. And the important thing to know is these programs, they run outside of the browser, right? They can run anywhere on any device. Okay, unlike our React apps, which require a browser, right? So traditionally, these backend programs, they were written in languages like C and C++ and Java, Ruby, PHP, Python, right? You couldn't write this stuff in JavaScript because JavaScript only ran in browsers. And browsers are sandboxed, right? Meaning websites can't do low-level things like reading and writing from the file system. Luckily, right? That would be bad if they could. So back in 2009, this guy named Ryan Dahl, what he did is he extracted the JavaScript engine from Chrome and he made it available as a standalone runtime environment so that we can run JavaScript on a computer without a browser. Okay, so that engine and all of its counterparts are what's referred to as Node.js. Okay, it's that standalone runtime environment for JavaScript that was extracted from Chrome. That's Node.js. And for the first time, this opened up the world of native applications to JavaScript developers, which is really, really cool. Because now you can build these programs without having to learn a new language. So let's see it in action. You don't have to follow along with this just yet. You can just watch. I'm going to show you an example of a Node program. So I'm just going to create a file and I'm going to call it create.js. And inside of this create.js file, I'm going to write a Node program. So the first thing I'm going to do is I'm going to import a dependency. So I'm going to say const fs equals require fs. I'm going to import this dependency called fs. And then I'm going to create a variable. I'm going to call it dir. And inside of that variable, I'm just going to save the current timestamp. Okay. Now I'm going to call a function from that fs dependency. I'm going to say fs.makedir sync. I'm going to pass in that directory, that timestamp, convert it to a string. And then inside of a for loop, what I'm going to do is I'm going to create files inside of that directory. So if I said for let I equals 1, while I is less than or equal to 100, plus plus, right? This is all just JavaScript. This is stuff that you should have learned before. And then we can call another function from that dependency. We can say write file sync. We're going to give it a path, give it the index.txt. So we're going to say create a file, a text file at this location. And inside of that text file, we're just going to say hello from index I. Okay, and that's it. That is a Node program. Let's see what happens when we run it. If we save that out and we run just node create.js, and take a look at that directory now. We now have this folder with the name of the current timestamp, and it automatically created 100 different text files for us. And inside of each one of these text files, we have that message. Hello from index 68. Hello from index 73. Awesome, right? Now, if for some odd reason we had to create 100 different text files, we just saved ourselves a ton of work by writing a simple JavaScript helper. Right? We're running JavaScript outside of the context of a browser. So you can see that even outside of web development, Node can be useful for automating everyday things. Right? You can make a request to a website and scrape information from the HTML. You can text a daily meme to a friend, or change the file extension of every file in a directory, or create a Slack bot, right? There's a lot of different things that we can do with this server-side JavaScript. It's now useful for more than just building websites, which is really, really cool. So just like everything else in the development world, running JavaScript without a browser has pros and cons. So let's talk about those real quick. Pros of using JavaScript with Node. You can find these in the training kit as well. But pros of running JavaScript outside of the browser is you no longer have to learn multiple languages to be a full stack developer, right? Traditionally, you would have to learn other languages like Python or PHP or something like that. Although it's not a bad idea to learn multiple languages, you don't have to do it to be a full stack developer anymore. Okay, another pro is we can share code between the front end and the back end, which is pretty cool, right? If we write a JavaScript function, a helper function for our React apps, we can use that same function in our backend if we need to. Okay, another pro is we can install NPM modules, which gives us a lot of potential functionality. Right, those NPM modules that we use a lot in our front end, we can use those in our backend as well. Okay, cons. The fact that we have access to NPM can make a lot of low quality and buggy libraries available to our app. And as you'll find out, bugs in the backend, they're much more serious since they can result in lost data. right? No one wants to lose data in the back end. Another con is that JavaScript is an interpreted language. It's not compiled, which means it runs very, very slowly compared to other languages. Okay. Another con is JavaScript is single-threaded. Node is single-threaded, meaning that the node process can only run on one thread in your CPU, right? Your CPU can have lots of different threads running different processes, but only one of those can be node, right? Versus other languages which can run on multiple threads and offload workloads to different threads and communicate between them and so on and so forth. JavaScript can't do any of that. Okay, it's single-threaded. It can only run a single process. So it's important to use the right tool for the job when you're coding something, or you're going to run into issues later down the road. So with that in mind, what are some situations when Node would be a bad tech choice? When would Node be a bad tech choice? Any ideas? Microsoft, yes. Building a game, definitely. Embedded systems, definitely. Maybe like an iPhone app, right? You might not want to build an iPhone app with JavaScript, or maybe a native desktop app. JavaScript might not be the best choice. If you need something that's performant, that might need to run on multiple threads, right? Maybe JavaScript is not, maybe Node is not the best choice. That's why it's our responsibility as backend developers to know a lot of different tools so that we can make the best choice for different projects, right? We do have like Electron, right? Or React Native, or these frameworks that allow you to build native applications with JavaScript. But they come with a lot of drawbacks, and they kill performance. Okay, so it's kind of our responsibility to make sure that doesn't happen, to make sure we're not building apps that are really, really slow. Anything with video, yeah, for sure. So when would Node be a good tech choice? Would Node be a good tech choice? Building a portfolio, a fishing bot in World of Warcraft, yeah, sure. Scraper, web development, single page app, right? Yeah, anything that we need to develop quickly but doesn't really depend heavily on performance. So a web server, right? Or maybe some simple scripting or some simple automation. Yeah, Slack bots, right? These things that aren't super dependent on performance. Let's talk about web servers a little bit more. Okay, hopefully you learned in previous lectures what a web server is. This is a diagram that I like to show students when I'm introducing HTTP, if you haven't seen this before. But a backend, a web server, really just has one purpose, okay? Its single purpose is to respond to incoming HTTP requests. Okay, that's its sole purpose, to respond to those HTTP requests. So when you go to a URL in your browser, right, this is you, right, you're on your laptop. If you go to a URL in your browser, the browser is going to make a GET request to a web server, right? It's going to route that GET request through the internet, through all of these roads, and it's going to arrive at that web server, okay? And it's that web server's responsibility to gather whatever info is needed and build a response of some kind in some kind of data format like JSON or HTML, and send that response back to the client, right? That's the web server's sole purpose. So this web server here at the end of the line, this is what we're going to be building in this block. This is our back end. Okay, this is what we're going to be focusing on, building these web servers. Okay, so let's build out a basic web server with Node. See what it takes. So make sure you have the project cloned down. Make sure you have your npm install done. And open it up in your code editor. Okay, so if whoever asked the question about what multiple threads means, I believe I answered that. Feel free to ask again if I did not cover it well enough. All right, so open up the project in your code editor and get rid of that folder that I generated. And let's build a basic web server. Okay, one more time, multi-thread. So what does multi-threaded mean or single-threaded mean? Essentially, when your computer is running, okay, your CPU has a bunch of different processes running at the same time, right? If you go into your activity monitor, you'll see that there's a whole bunch of processes running on your computer at the same time, right? When Node is running, it's single-threaded, which means it can only run on one of these processes at a time, okay? It can't run multiple processes or multiple threads, okay? It's single-threaded. It can only run a single process. Versus other languages, other backend languages like Go, for example, it can run multiple threads at the same time, and it can communicate between them. It can offload workloads to new threads. You can use multiple processors on your computer if you have multiple processors. But Node can't do that, okay? It only runs on a single one of these threads. Yeah, or task manager if you're in Windows. All right, so once you're in the project, let's create a new file and just call it server.js. Okay, and the first thing we're going to write in our new Node program is we're going to import a dependency. We're going to say const http equals require http. Okay, this require syntax might look a little bit different than what you're used to. When you're coding in React, you probably saw something like import http from http, right? Well, this is actually newer syntax. Okay, it's supported when you're working with React because you have a transpiler, but we don't use a transpiler for Node. We just run the raw code. Okay, and Node doesn't really support this import syntax quite yet. So we use the older method of importing, which is just require. It does the same thing behind the scenes, though. Okay, we're just importing this dependency called HTTP. Okay, who knows where this HTTP dependency, where is this coming from? Okay, we didn't run npm install HTTP, right? We didn't specifically install that. Where is it coming from? It's not a file because it's not a local path, right? So it's actually just part of the Node standard library. Okay, the Node runtime, it comes included with a bunch of built-in libraries and functions that are really, really useful. Okay, if you check out this link, you can look through all of the different libraries and functions that Node gives us by default. Okay, a lot of really useful stuff. In this case, we're using the HTTP module, which comes with a lot of stuff for creating servers, web servers. All right, so we import HTTP. Now let's create a variable. We're going to call it server. So const server equals, and we're going to call a function on HTTP called create server. So we're going to say http.create server. And that create server function, that accepts a single parameter, which is just a callback function. It's called the route handler function. Okay, so it's just a callback, and it has two parameters, a request parameter and a response parameter. Okay, we use the request parameter that gives us information about the HTTP request, and the response parameter that allows us to send information back to the client. So most of the time you'll see these shortened. You'll see the names shortened to REQ and RES, rec and res. Okay, and first thing that we need to do is send back a status code to the client. So let's say res.statuscode and give it a status code of 200. Okay, as a reminder, a status code of 200 just means a successful response. Okay, let's send back a response header. Let's say res.set header of content type and set it to application/JSON. We're telling the client that we're returning some JSON data. Okay, and then let's return some JSON data. Let's say res.write, give it a template string, and let's just return a JSON object. We'll say message, hello world. And then just send that response back to the client by saying res.end. So now anytime someone visits our web server, anytime they make an HTTP request to our web server, it's going to call this function and return this response, right? In this case, yes, the quotes are required because the Node server by default doesn't stringify our JSON. So we're just sending back a string for now. You'll see how we can fix this in a minute. And then last thing we need to do is actually start the server. So let's just say server.listen. We're going to listen on port 8080. So the first parameter is the port. And then just give it a callback as the second parameter. And inside of that callback, just log some kind of message. So let's say console.log, and we'll say server started at, we'll give the address, HTTP localhost port 8080. And that's it. That's all that takes to build a simple web server with Node. So now if you go try and run this, run node server.js, see what happens. So if I come to my terminal and I say node server.js, we'll get a message, server started at localhost port 8080. And notice when we run it, the program kind of hangs, right? It just kind of sits there. It doesn't stop, it just kind of hangs. And that's because it's waiting for incoming connections, right? It's waiting for an incoming HTTP connection. Web servers have to be continuously listening in order to accept requests. So once you have that running, try going to that URL in your browser and see what happens. Try going to localhost port 8080. Boom, look at that. We get a JSON response with a message of hello world. Okay, you can now deploy this server. You deploy it to the internet, and if I went to your domain, I would see this hello world message. Okay, notice how our log message, when we say console.log in our Node program, notice that it logs in our terminal and not our browser. Our browser didn't log anything. That console's empty. But it logged in our terminal instead. Okay, and that's because our Node program is now independently running on our computer. Our browser has no idea that our server is running Node. Okay, all it does is make a GET request. It doesn't care what it's built in. It could be built in C++ for all it cares, as long as it's getting a proper response to its GET request, right? So this Node server is running in isolation. It doesn't have to have a browser to execute this JavaScript code. Try stopping your server. If you hit Control-C, that should stop your server. It'll stop that process. And try going to that page again, that port 8080. Try refreshing it. And you get an unable to connect, right? Because our server is no longer running. It's no longer listening for those connections. Start it up again, and you'll get your message back. All right, questions so far? Okay, is a web server a computer or code that responds to the HTTP request from the client? Good question. So the web server itself is the program that's running on the computer, right? So you have a server. The server is just a computer that's running, right? The server right here at the end of the line. This is just a computer in some data center somewhere, or maybe even just in your house. That's just a computer that's running a specialized piece of software that responds to requests. Okay, the software itself is the web server. Good question. Okay, so what are APIs, REST APIs, SOAP APIs? We will cover that in a little bit. Can I explain the response.header part of the code? Sure. So if you remember the structure of an HTTP request, this is what the structure looks like for an HTTP request. This is the protocol, right? We have the request, and the request is going to have like a method. It's going to have a URL. It's going to have some request headers, maybe a request body. And then there's going to be the response, right? And the response is going to have a status code, some response headers, and maybe a response body. Okay, when we receive a response, we have to know what type of data it is. We have to know if it's JSON, or maybe it's XML, or maybe it's HTML. We don't really know, or our program doesn't really know what that response is unless we get a specific header called content type, which tells us what format it is. Okay, so if the server, if it returns JSON, we have to specifically say in our content type header that this response is JSON. Okay, and we do that by setting this response header of content type to application/JSON. Okay, we'll talk more about this in a bit later tonight. Do I have a specific extension that's displaying my message this way? That's just what Firefox does. If you're in Firefox, it should do that automatically. If you're in like Safari or Chrome, you might have to install an extension that displays it like that. I can just view that's what just the raw response looks like. This is what it looks like formatted. All right, let's take a quick break, catch up with the code, mess around with it a little bit, ask any questions that you have in Slido. I'll see you in 5 minutes. Okay, come on back. So some good questions here. For those of you that are asking for the start command, all I did is I ran node server.js. Okay, and that will start your server. It's going to execute that JavaScript file with node. Okay. Let's see, why didn't I use the REQ parameter, but only the RES parameter? Because we're not using anything from the request yet. Okay, the REQ parameter, that gives us information about the request, things like the user's IP address or the request headers, things like that, okay, or the request body. We're not using anything from the request just yet, so we don't need to use REQ yet. We will use that in just a minute, so hang tight. What other content type options are there? Well, any kind of data type, right? You could have a data type for HTML, which would be text/HTML. You could have a data type for XML, which would be application/XML, or like audio, which could be like audio/MPEG for an MP3. Pretty much any type of data has a specific content type header. How many types of web servers are there? I think that's kind of a vague question, because the web server itself, that's just the software that's running, right? So how many different types of web servers are there? Well, the answer would be how many different types of coding languages are there? That would probably be the answer that you can get right there. So you can build a web server in pretty much any language. Is Node.js in high demand? Yes, it's in very high demand right now. I would say the majority of my day-to-day work is Node.js right now. A lot of companies are adopting it. A lot of large companies are adopting it, and smaller companies. So knowing it is a very valuable skill in the field right now. On an enterprise level, a lot of the older, bigger companies don't really use it because it's such a new language. So if you're looking to get into like enterprise stuff, then that's when you're going to need to learn Java or .NET. But a lot of the newer tech companies, a lot of the startups, I think companies like that, most of them are using Node right now. Okay, why not store the port in a variable? You absolutely could. Yep. If you wanted to store this in a variable and say const port equals 8080, and then pass it into there, and then even use it inside of your message, you could do that. Yep. It's a little bit more dry. I like that. Good question, Brendan. Yes, the content type is the media that your web server is serving. Okay, in this case, we're serving JSON. So we're going to set the content type to JSON, but say we were serving an image, then maybe our content type would be image/JPEG, or so on and so forth. Whatever your web server is serving, it should have the correct content type. All right. I'll get to some of these other questions later, but let's move on. Mandy, I'm not sure why your server could be trying to download the file. Yep, typo. Good catch. So this is a really simple web server, right? Obviously, it's not very practical for a real production application. We still need things like routing, data parsing, working with headers, saving to databases, all that good stuff that goes into building and backend. We could write all that functionality just from scratch, But for our purposes right now, that would be kind of impractical. So instead, we can install an NPM library into our Node app called Express. Express.js. So just like how the React framework, just like how React helps us work with the DOM on the front end, right? It helps us work with that DOM. It gives us helper functions and does a lot of stuff behind the scenes. Express is going to help us work with the HTTP protocol on the back end. So it's a lot like React for the back end. Okay, it's just a framework that sits on top of this HTTP module and helps with a lot of boilerplate. So when you get some time, feel free to browse the documentation to see all the cool stuff you can do with it. It makes writing APIs much, much easier. Okay, so let's install it. So just jump into your terminal, make sure you stop your server by hitting Control-C, and just type npm install --save Express. Same as you would install a dependency in your front end, right? Remember, this is just JavaScript. So we can still use npm and all of its libraries, all of its features. So go ahead and install Express. It should actually go fast because it's already installed, but I just wanted to show you the command. So once that's installed, go ahead and jump back into your code. And let's convert this raw HTTP server. Let's convert this into an Express app. So instead of importing HTTP, we're going to import Express. So we're going to say const express equals require Express. We're going to create a new instance of this app. Okay, I'm going to go ahead and just comment this handler out for now. Let's create a new instance of our Express application by just saying const server equals Express. It's just a function that we call. Okay, you can call this server, you can call it app, you can call it whatever you want. And now that we're using Express, we have some helper functions that help us to define endpoints. So instead of just saying create server and just having like a global handler for every single request, regardless of the endpoint, regardless of the route, we can now specify specific handlers for specific routes and specific methods. So to do that, we can just say server.get for a get request and give it an endpoint of /. So a get request for the root route, run this handler. And then we can just pass the same callback function as before with our request and our response. Okay, now inside of that request handler, so before we were doing all this boilerplate, right? We were setting a status code, we were setting the JSON header, content type header, we were writing the response to the endpoint, we were writing the payload to the response, and we were sending it off using res.end. When we're using Express, we don't have to do all of that. We can just call a single function, and we can say res.json. And we can just pass an object, an actual object, not a string this time. Say message, hello world. And that's going to do the same thing as our server was doing before, but with much less code. And then the syntax for starting our server, that's actually exactly the same. So we can still just leave it as it is. Calling server.listen, passing the port, and having a callback message. So save that file and start your server again. Right now, we're not using like any special programs to restart our server. We will in the future. But for now, whenever you make a change to your server.js file, you have to come to your terminal and restart your server. So just hit Control-C and then rerun node server.js. Okay, we'll figure out, or we'll learn in the future how to make that automatically restart. But for now, just restart it manually. Okay, so now if we go to the localhost 8080 endpoint, refresh it, and we get the same message. We get that same hello world message, but with much less code. Okay, so our React app, or our front end, can now call this endpoint, right? It could call localhost port 8080, make a request with Axios, it could parse that JSON response and display this hello world message to your front end, to your users. This is now a fully fledged backend, a fully fledged API. So we can have as many routes as we want. That's the beauty of Express, right? Right before we just had a single callback function, but now we have one for specific routes. So we can define the root route. Let's try defining another route. Just right below, let's say server.get. So a get request, but this time let's do /lambda instead of the root route. So now if somebody comes to our API and they make a request to /lambda, it's going to run this callback function instead of this one, instead of the other one. So this time, instead of returning a JSON object, let's return a redirect. This is another feature that Express gives us. It allows us to redirect pretty easily. So we can say res.redirect. Maybe we want to redirect our users to school.com. So now when someone visits /lambda, Express behind the scenes is going to return all of the proper headers, all of the proper response code, and essentially redirect our browser to lambdaschool.com. Try saving that and then try restarting your server and going to that endpoint and see what happens. So now if we go to localhost port 8080 /lambda, our Express server is going to redirect us to lambdaschool.com. See, Express gives us a lot of power without much code, which is really, really useful. So in a real world application, in a real production application, our route handler functions, these callback functions, they're going to do a little more than this, right? They're going to have to query a database, validate data, do a lot of different stuff. We're going to dive deeper into that stuff in later lectures. But for now, let's just pull some data from another JavaScript file to kind of simulate a database and display something more dynamic than hello world. So if you look at the files that came with the guided project, there's this file called users.js. Open that up and see what's in there. All it's doing is it's exporting an array with 3 user objects. Okay, we've got Jane Doe, John Doe, and Jack Doe. Let's create an endpoint so that clients can request this data, right? Let's say that this is our database and we want to display it to our clients. Let's create an endpoint for that. So let's say server, let's create a get request /users. So server.get /users, same request and response, same route handler. Now we need to return that users array somehow. So let's import it first. So jump to the top and let's say const users equals require. And let's require that local file this time. We're not requiring a node module. We're not requiring something from the standard library, but we actually want to require another JavaScript file. So we can just say require /users.js. Okay, and that's going to import that actual file, this data right here. And you can even leave off the .js extension if you want to, and it'll still find that file. Okay, so once we import it, we can just return it in that endpoint. It's not inside of our get request for users. Let's just call res.json users. I'm going to go ahead and get rid of this raw server. Actually, I'll move it to a different file just so we can keep it. A little bit. Okay. So now anytime we go to /users in our browser, we're going to get a list of those users, right? We're going to get a list of these users from our fake database. So let's try it out. Save your file, restart your server. And try to go to /users. And look at that, we now have a list of our users from our fake database. Okay, our APIs really come together here. We have a lot of cool functionality without having to write much code for it. All right, questions so far? Whoa, we have a lot of questions. All right, so would you create a database outside and import it into your server as so? Yes, so actually during your project tonight, you're going to be working with a real database, but there will be a file, an external file that makes all of the functions available to you. So yes, if you were using a real database, essentially it would be masked behind a module like this. So you would just import the database file, the database functions, and call them as normal. You'll see how to do that more in tonight's project. So let's see, another question. When we use React, we have to import React. How is it that Node is imported right away? Good question. So Node itself is not a library. Okay, React is a library. It's a framework that we have to import and actually use in our JavaScript code. Node is a runtime environment. Okay, it's not a library, so we don't have to import it. All Node does is it runs our JavaScript file. It kind of acts as the browser, right? How the browser parses our JavaScript and it runs our JavaScript for our front ends, Node parses and runs our JavaScript for the back end. So we don't explicitly import Node because it's not a library. So it's an environment. Okay, so through HTTP methods like the ones we did with Axios, the client can update the list or do whatever. Yep, so now we just define endpoints and our front end, or Axios, is able to call these endpoints to perform specific tasks. Right? In this case, just getting some data, but we'll see more complicated examples in a minute. Okay, why is it that we don't need quotes around the message when using Express? So when we return this JSON object, why don't we need quotes like we needed in our server? Because Express comes with a lot of stuff behind the hood. behind the scenes. Okay, so essentially when we return a JSON object to our HTTP response, it has to be stringified. It has to be converted from an actual object into a string. Okay, and that's a process that most of the time should happen kind of behind the scenes. You shouldn't really know that that's happening. But in this case with our raw server, it doesn't do that automatically. So we just have to return a string. Okay, the HTTP protocol doesn't know anything about JSON. It can't use JSON specifically in the response body. It just uses strings. So we have to encode that JSON object to a string before we send it off to the client. In this case, Express does it automatically for us just by calling .json. Okay. Can you use Yarn to pull node modules, or is NPM better? I'm going to be using NPM throughout the majority of this block. I think Lambda is kind of moving towards using NPM over Yarn. Yarn was originally built to solve problems that NPM had, but now NPM solved most of those problems itself, so there's really not much need to use Yarn anymore. Definitely feel free to use it if you prefer it over NPM, but NPM works just fine for most cases. So you can use Yarn if you'd like, but I won't be using it at all. So if you run into errors, you're on your own. Let's see, I'm not sure what your question is. Whoever asked, then you could use React plus Node in the same file. Yeah, I mean, if you were building a Node app that did something with React, you could import React in your Node app. That would definitely work. Since Node is not a library, right? It's a runtime environment. So you could still import React in Node and do maybe like server-side rendering, for example. Are you going to learn how to do server-side rendering? No, not in this block. That's going to be something that you'll have to learn on your own if you're interested. Are there any projects out there in the industry only with pure Node and not with Express? Yeah, definitely. There's a bunch of different Node frameworks that do the same thing, that give us all of these helpers. Right? In this case, we're using Express because it's one of the most popular ones, but there's also one called Happy. There's one called Koa. There's one called Sales. They all do different things and they all have different levels of abstraction. In this case, Express is just one of the most popular ones and it keeps things pretty simple. So yeah, you could write your API in just pure Node. You could write it in Express. You could write it in some other framework. They all pretty much do the same thing. Okay, if you're getting response.json is not a function, make sure you check for typos. Make sure your parameters are in the correct order. Okay, can I explain what module.exports is in the user's file? Yeah, that's just exporting an object from this file. So when we import this file into our server, it has to know what to import. We'll go into this more in depth later on, but essentially, if we want to import a file into another file, we have to export something. So we're just saying module.exports. That's the same as saying like export default. This is probably what you're used to, right? It's the same thing as that, only older syntax. It's compatible with Node. All right, let's move on. So what if we want our routes to contain like parameters or variables? If you remember that from React Router. Remember in React Router, you could define like chunks of your URL that could be read into a variable, like some value could be read into a variable called a parameter. We can actually do that same thing with Express. Okay, let's say we wanted to get a specific user by ID instead of getting all of the users at once. Okay, we can do that just by saying server.get. We're going to define a new endpoint, but this time we're going to define the route as users / and we're going to say : ID. give it the regular callback function. Okay, this should be familiar syntax because you've used this in React Router. Okay, that's saying when you go to any route that starts with users and ends with some string, so if you go to users/1 or users/15, that value, that chunk of your route is going to get pulled out of the URL and saved in a variable called ID and made available in our actual code, so that we can then use that ID to find the user in the database, for example. Okay, so if we define a parameter in our route with Express, we can get that value just by saying const ID equals request.body.id. Okay, see, we're now using the request object because we're pulling something from that request data, and that will be our user ID. Okay, we could even destructure this if you wanted to destructure it. You could say const destructured ID equals request.body. Doesn't really make the syntax much shorter in this case. So what if we have this users array, right? This array of different users. How do we pull out a specific user by their ID? Does anybody remember the JavaScript function that we can call to find a specific user by their ID? Good, yeah, we can use .find or .filter. Let's use .find. So if we want to pull that specific user from the users array, find them by their ID, we can just call users.find and then do a comparison on the ID. So you can name the parameter whatever you want and then just call whatever your parameter name .id. If it's equal to ID, then return it. And that will find our specific user by ID. Okay, so now that we pull that single user out of our users array, we find them by the ID. We can run an if statement. We can say if that user actually exists, if that returns something, then return it to the client just by saying res.json user. Otherwise, if that didn't return anything, return an error. So in that case, maybe we can return a status of 404. So you can say res.status.404 and then give an error message of user not found. Okay. So once you get that, save your server file, restart your server, and try going to users/some ID, /1 or /5. So if I try and go to users/1, now it can't read property ID of undefined. That is because we forgot something. Yes, it is request.params, my mistake. Thanks, Joshua. Not request.body, request.params. Let's try that again. Okay, try and request user/1. And look at that. We now have the user of ID 1, Jane Doe. Try request a user with ID 2. And we get John Doe. User of ID 3, we get Jack Doe. User of ID 4, we get a user not found error. Okay, and if you look at the headers, well, it doesn't show the status code. If you look at the request, you'll see that we get a 404. Where does that show? Oh, there it is. Yeah, 404. Sure, let me copy everything I've got so far and post it in Slack if you're having trouble keeping up. Okay, could you do a, let's see, a question. Could you do a const callback function equals res rec equals object and reuse it? In this case, no. You couldn't put this callback function in a variable and reuse it because each callback is different, right? If we were trying to reuse the hello world callback for our get user by ID callback, then it would return hello world when we're trying to get a user by their ID. But you can't really use that, reuse that callback function because each one is unique. Each one is different. When did we install Express? Right before we converted this over to an Express app. Express is actually already installed in the package.json, but I just wanted to demonstrate how you would install it just with npm install Express, like you install any other dependency. Okay. Yep, so another question. So for React application, we use import destructured name from library name. But for Node applications, we use const name destructured name equals require library name. Yeah. So essentially in your React apps, you were using syntax like this, right? I was destructuring the value of name from that import. You can do the same thing with require by just saying const name equals require sunlit. Okay, there's actually some internal differences between the two as to how they work with exports and things like that, but we don't need to get into that right now. Just know that they're essentially doing the same thing. Okay, good question. So when we define routes and create endpoints on our web server like this, we're building what's called an API, okay, an application programming interface. This is what the API stands for, application programming interface. An API is essentially a piece of software that that makes some of its functions available to other programs. Okay, so remember when you were working with the DOM, the DOM API, you'd call like document.getElementById, right? Which the DOM API was just exposing functions to our JavaScript app that helped us work with the DOM, right? That was what's considered an API. In the context of a web server like this, an API is when the route handler functions, these callback functions, these are exposed essentially to the internet. We're making them public by exposing them behind endpoints. Okay, each one of these endpoints are used to manage like some kind of resource, right? A user or a product or an order or whatever. And these resources, the manipulation and the querying of these resources is made available publicly through our API, our application programming interface. So with our current setup, our current API, clients can easily work with our user resource by getting a list of them all, right? By calling get/users. They can get a single one by calling get user/ID. This is our API. Okay, we're exposing this functionality behind endpoints. Okay, question. What other types of functionality should a resource have other than list and get by ID? So we have those two already, right? We have those two endpoints. What other types of functionality do we need? What do you think? We need create and delete, edit and delete, maybe get by something other than ID, put and delete, right? Create, read, update, delete. This should sound pretty familiar, right? This is an acronym that gets thrown around a lot. CRUD, right? CRUD, create, read, update, delete. CRUD operations. When we build an API, each one of our resources, so our user resource, our Lambda resource or whatever, maybe we have some orders or products, each one of our resources should have basic CRUD operations available, right? They should have endpoints that expose the operations of creating a resource, of reading a resource, maybe a list of resources and a single resource, of updating a resource and deleting a resource, okay, CRUD. So right now we have the reading operations for our user's resource. But let's create another endpoint for creating a resource, for creating a user. Okay, what type of HTTP method is used for creating resources? Post, yep. We need to create a post request, a post endpoint. So let's say server.post. And let's give it an endpoint of /users. The same callback function with a request and a response. Now inside of this route handler, let's just create a new user object. So let's just say const new user equals an object. And if you look at our users, our fake users database, we have two columns, right? We have an ID column and a name. So we need to specify both of those when we're creating a new user. So in our new user, let's just say ID. Let's set the ID to the user's length +1. So it automatically increments that ID. And then the name, just hard code it for now, and we'll say Bob Doe. Okay, so we've got a new user object. Let's simulate the functionality of saving that to the database. So if we're using an actual database, we might call like an insert function or a create function that actually inserts it into the database. For now, since we're just dealing with a fake database, we can just say users.push and push that new user onto the user's object. And then let's return a res. Let's return a status code of 201, if you remember that one. That means a successful response and a resource was created. And just return the new user. Cool. Simple enough, right? So now when we get a post request, when our web server, when it receives a post request for /users, it's going to generate a new user with the name of Bob Doe, and it's going to push it to our users array and then return the new user object. Okay, but how do we test this endpoint? We can't make a post request from our browser. Our browser only makes GET requests. Okay, we could test maybe like from a React app using Axios. Or we could test from the terminal using curl. But most of those methods, they're not very practical and they get very verbose. So there's actually a lot of tools out there that can help us manually test our APIs. You guys got it. Feel free to use whatever app or method you like the most. If you prefer to use curl in the command line in the terminal, use that. If you prefer to use some other application, Postman or PA or some other REST client, feel free to use that. The one I'm going to be working on from here, or working from here on out, is called Insomnia. Okay, so make sure you have something installed, whether it's Insomnia or Postman, whatever you prefer. And open it up. Okay, and once you get your endpoint written, open up your HTTP client, and let's try and test this post endpoint. So Insomnia, it gives us a really nice user interface to manually call our endpoints, to make post requests, to make put requests, get requests, to send request data, to send some JSON, maybe see our response details, everything that's needed to test an API. Right? The browser only goes so far. It can only make GET requests, and that's it. So now that we have Insomnia open, let's restart our server. And let's create a new request. So just hit this plus icon, hit new request. Let's create one just for get index. Let's get that root route and see if we get that hello world message. So call it get index. The URL is going to be http://localhost port 8080 / just the index route, and hit send. Okay, if everything is working as it should, you should see a 200 OK status and our hello world message, just like we did in the browser, right? Because it's just making a GET request. Let's try making a request to test our other GET endpoints. So remember we have, let's not do the Lambda one, but let's test our users and our users by ID as well. So you can hit this arrow right next to the request, Get this drop-down menu and you can hit duplicate. That will duplicate this request. Let's call this one get users. Hit create. Get users, it's going to be a get request, but instead of the root route, we're going to request /users. Hit send. And we get a list of our users. Try creating one for getting a user by ID. So duplicate that request, call it get user by ID. And this time make a get request to users/1. And you should see Jane Doe. Okay, let's make a new request to test our post endpoint. So let's duplicate that. We'll call it create user. Okay, create user is going to call /users. But instead of a get request, it's going to be a post request. So hit this drop-down arrow and change it from a get request to a post request. And hit send. And look at that, we get a response with Bob Doe and an ID of 4 with a 201 created status. So now if we jump back over into our get users request and we send that again, we now have 4 users coming back instead of 3. Cool, so now we can test all of our endpoints regardless of the method just by using Insomnia. All right, let's take another 5-minute break. Take the chance to catch up or step away for a minute. Mess around with Insomnia, see all the different options that you can set. And I'll see you in 5. Okay, come on back. Remember to try and be succinct with your Slido questions. I'm getting a lot of questions that are kind of vague. So make sure you include context as to what you're confused about or what you want to see again. And for a lot of these questions that are off topic, I'll be happy to answer them in Slack after the lecture. All right, how's everyone feeling so far? I know this is a lot to take in. Make sure you update your poll in Slido so I kind of get a feel for how everyone's feeling. We're at a 4.1 average right now, which is really good. Yeah, if you feel like this is just kind of a lot to take in, I totally understand. I promise it'll make more sense as we move along. Just give yourself time to let it soak in and keep practicing. It'll click for you, I promise. All right, the code is all posted above. We've got the server raw and the server.js. That is the most recent code. So we just scroll up a little bit, it should be there. Yeah. I'm not sure how to say your name. Is it Shirag? 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 I'm sorry if I mispronounced that. Chirag, is that right? Cool. Do I usually push up code after lectures? Yep, I'll push up everything I have to the repo so you can compare and clone and do whatever you need to do. Question from Slido, I thought mutability is dangerous, but now we just changed the list of users. Should we save the original one or that's okay with the backend? So this is more just like a demonstration. Okay, yes, we're mutating this user's data, which probably isn't the best way to do it, but you would never do this in production, right? If this was an actual production app, your database would be a real database, not just some file. So this mutating this user's data is really just for demonstration purposes, okay, to keep things simple for now without having to use an actual database. So I'm glad that raised some red flags for you, right? That we're mutating data. That's not a good thing most of the time, but for simplicity's sake, it keeps things easy to demonstrate. We'll start using real databases soon enough, so we don't have to worry about that. Is it normal to get an invalid or unexpected token when copying my code? No, I don't think so. I know sometimes when you post code into Slack, it can do weird things with like the quotes. So, I mean, if you're having issues with just pasting my code directly and trying to run it, then maybe it's like trying to do something with the code or something with the quotes. And in that case, you can just clone from the GitHub repo and it should, when we're done, I'll push everything up and it should all be good. All right, let's move on to the last piece of this. So if you remember our HTTP protocol, the structure of an HTTP protocol, this is kind of what it looks like behind the scenes, right? You have a request and a response, and both of them have headers and a potential body. So, Jose, are you sure you want to delete /Windows? Yes, I'm sure. So question, which request methods can include a request body? So all of our methods can contain a request or a response body, right? But which of our methods can contain a request body? If you remember all of our different methods, which you can find here, which of our methods can contain a body, a request body? Okay, this request body right here. Everything can have a response body. Get requests can have a response body, right? But not everything can have a request body. Put, right? Put can have a request body. Post can have a request body. Patch can have a request body, right? None of the other ones can. All of the other ones don't have a body. So now that we have the ability to send a request body with Insomnia, if you look at Insomnia, when you make a request, you can include a body with it, right? You can include a JSON body, an XML body, binary file, multi-part form. You can send all these different types of request bodies along with your request. So let's alter our code so that instead of hard coding our name when we're creating a user, let's allow Insomnia to send that name along with the request as part of the request body. So first things first, this is kind of a strange detail that we have to do that we're going to talk about later, but we have to install some middleware. We're going to talk about middleware a lot next week, but for now, just type server, go up to the top, and right below your instance, your Express instance, just call server.use and say express.json. Call it as a function. Okay. That just allows us to parse JSON request bodies, which is what we want right now for our post endpoint. So make sure you put that at the top. Now inside of our post request, instead of hard coding this name, instead of hard coding Bob Doe, let's use something from the request. So what we can actually do in Express is we can just say request.body.name. And what that's saying is when we send a post request with Insomnia and we send a JSON request body, pull the value of name from that JSON object and use it when we're actually creating the user. So use request.body.name instead of that hard-coded Bobdo string. And now if we save that and restart our server and go into Insomnia, for our post request, we can go down here to body, click the arrow next to body, and click on JSON. We want to send some JSON data with our request. So once we click JSON, we can define an actual JSON request body by just defining an object. And we can say name and put your own name in there. So when we create a new user, it should have your name. And send that along to the server. Now you should see a new user created with your name. In this case, Jason. So now if we go to users and list our users out, look at that. We now have a new user created with a dynamic name that we sent along with the post request, right? That name is not hard-coded in the server anywhere. We're sending it as part of the request. And the server finds it. It finds it from that request body and it uses it when it creates that user. So if you remember our HTTP spec, right, it's always our HTTP requests, they always have a method and a URL, they have some request headers, and they have a potential request body that gets sent. It's sent to the web server. And in this case, this is our request body, okay? And we access that request body in our handler by just calling request.body. And then we have a response status code, some response headers, and a response body. And in Insomnia, that's the stuff that comes through over here on the right. This is our response body. These are our response headers. Okay. All right, questions? When we send body in JSON format using Insomnia, are we faking an HTTP request from the client side? Yes. Well, we're not really faking it. We're making a real request. Remember, our server, it runs in isolation from the browser. So our server can respond to requests from anything. All right, our server can respond to a request from a browser. It can respond to a request like from your React app. It can respond to a request from Insomnia, or maybe an iPhone app, or a desktop app, or a curl command in the terminal. It can respond to anything as long as it follows that HTTP spec, right? As long as it sends the correct request headers and request body and things like that. So this isn't really like faking a request from our client. This is making a real request. So when we call post, the post endpoint, it adds to the users array, but it doesn't update locally in VS Code. Where is the data actually being saved? Good question. In this case, we're just saving it in memory. Right? We're not working with a real database, we're just working with a fake database. It doesn't actually update the user's file because this data just gets pulled into memory and then it changes the data that's in memory. So that's why if you restart your server, you'll start with a fresh set of data. Any of the changes that you made will be gone. And that's because this is just changing stuff in memory. This is a non-persistent method of storage. So we're going to talk about persistent storage later on when we start talking about databases. But for now, we're just working with this non-persistent data. So another question, whatever we send in the Axios from the front-end application, we get that content in the request body. Yep. So now if you make an Axios request, a post request with a request body, you can just access that data right here in request.body. It gets parsed for us. Okay, if you're getting a syntax error from the code you copy from Slack, yeah, I don't know what to tell you there. Maybe just wait until I push up to GitHub and then pull it down. Sometimes Slack does weird stuff with the syntax. So I apologize for that. All right, take the next 5 minutes. Okay, take the next 5 minutes and try and implement a put request and a delete request for our users resource. So following the same format of our other requests, see if you can implement a put request and a delete request and then test them out in Insomnia. Okay, I'll give you about 5 minutes to do that on your own and then we'll go through it as the last thing tonight. Yeah, sure. I'll post those pictures in the Notepad channel if that works. Oh, it looks like they're already posted. Jules and Mandy, beat me to it. Both of those images are in the WebPT10 Notepad channel. Thanks for posting those. Oh, I forgot about this question. So whoever asked, so a web server is a computer that responds to requests made by a client. So what are APIs and REST APIs, SOAP APIs? So I believe I answered that when we were talking about APIs, but just to reiterate, remember our web server is the computer program that responds to those HTTP requests. The API is the application programming interface, right? It's the endpoints that are made public. And REST APIs REST is basically just a pattern for organizing those endpoints, for organizing that API. And SOAP is another type of pattern that we're not going to talk about because it's outdated. But this pattern that we're using right now is called REST, and we're actually going to talk about that more on Thursday. So hang tight there. Okay, if you get that E adder in use error from Node, that means that you already have a server running in another tab, most likely. You have something that's already using that same port. So you just have to either close whatever is using that port or use a different port. Okay, why is it name : request.body.name? Couldn't it just be name with a blank string? I'm not quite sure what you're saying there. If this was just a blank string, then it wouldn't save any name at all. Right? We have to send that name from the request body somehow to our data store, to our database. So we have to specify request.body.name there. Is JSON used every time something is rendered to the screen? No, JSON is just a good data format to use when we're communicating between different services. There's a lot of different data formats that we could use, right? There's JSON, but there's also XML, there's TOML, YAML. There's a lot of different data formats, but JSON is the most popular and the most widely supported. All right, I kind of just talked a lot through that. Take the next minute and a half and see if you can implement the put and delete endpoints. Simulating the database functionality by just calling array methods. Okay. I know that wasn't a ton of time, But let's go over this. Let's see how we can add these last two CRUD operations to our user resource. The operation of updating and deleting. So if we want to update a user, an existing user in the database, remember we have to use the put method. The put method is used to update a resource. Let's say server.put for an endpoint of users. And since we have to update a specific user, not all of them, we're going to also specify an ID parameter. Okay, so the first thing before we update the user is we have to find the user, right? Or find the location of the user in that array. So if we want to do that, let's say const, let's try and find the index of the user that we're updating by just saying const index equals users dot find index. This is going to find the array index instead of the actual object. And do the same thing we did with our find function where we find it by the ID. Okay, so we get the index of the user that we're updating. Okay, and then let's just update, maybe if the request body contains a name, an updated name, let's update that name in our fake database. So let's say if the request.body.name exists, right? If that's something that's not null, then update it in our fake database by just saying users, the user at the index that we just found, change their name to the value of request.body.name. And then just return the updated user by saying res.json, the user at that index. Cool. Let's try it out. Save that, jump into and restart your server, jump into Insomnia, and duplicate your post request. We're going to name this update user. Instead of a post request, we're going to use a put request. So change that to put. We're going to update the user. Let's try updating the first user with the ID of 1. And we can send that same JSON request body. Send your own name. Try and update the user of ID 1 with your own name. And send that request. Okay, we should get a 200 OK, and we get that new user data. So now the ID of 1 is your name. If you try and request your list of users again, you'll see that the first user has been updated with the data that you sent. Exactly as we were expecting it. Perfect. Okay, what about our delete method? We want to delete a resource. Well, that's going to use the delete method, right? So we can say server.delete and have the same resource URL. We can say users/ID because we want to delete a specific user and not all of the users. Have the same callback. And this one's kind of interesting because we can use both the .find method and the .filter method at the same time to accomplish this task of deleting a user from that array. So let's find the user first to make sure it exists. So we'll do the same thing as you did in the get by ID function. Remember how we did that .find? You can actually just copy that if you want from line 29 and paste it into our delete, because we need to find the user before we delete it, right? We can't delete a user that doesn't exist. So let's find that user and then make sure you call request.params.id instead of just ID, because we don't have it set to a variable. And once we find that user, we need another if statement. We need to say if the user exists with that ID, then do something. If the user doesn't exist, then or return some kind of an error. Right? So if the user exists, we need to filter it out of that fake database, right? We can use the dot filter if you remember that. So we can say users equals users dot filter, and we're going to filter by that ID that we got from the request, from the URL. So we can say filter, don't include the user that has the ID of request.params.id. Now we'll take that user out of the array, and we can just return the new list of users by saying res.json users. Or since this is a delete request, we actually don't even have to return the list of users. We can just return an empty response. So what we could do is just say status 204 if you ever use that status. You can say res.status204.end. And instead of returning a resource or returning some data for a delete request, we can just say that it was successfully deleted and call it good. Right? There's a lot of different methods that you could use for a delete endpoint. Sometimes the developer likes to return the resource that was deleted. Sometimes the developer likes to return a list of all the other resources that still remain. In my personal preference, I like to return just an empty response. Okay, I'll leave that one up to you, so you can decide what you want to do there. And then if the user does not exist, then just return a 404 like we did before. So we can say res.status404.json, give it a message of user not found. Oh yeah, you're right, Fraud. Yeah, we don't want to say equals, we want to say doesn't equal. Good catch. So not equals in the filter, but not equals to. My mistake there. All right, cool. Let's save that and test it out in Insomnia. Test out those two, and well, we tested out put, but let's test out the delete. So restart your server, go back into Insomnia, duplicate your put request, call it delete user. And let's change that put, change it to a delete. And see what happens when you submit this. You actually don't have a request body with this one. Remember, delete requests, they don't need a request body. So we can just hit this arrow and go back down to no body. So we don't send a request body this time. And hit send. And we get a 500 error. Assignment to a constant variable. So we're trying to assign a new list of users with the user deleted, but users is a const. So who knows how we fix that? Notice how when we import users, we're naming it as a const. We need to change that to a let, right? Nice. Change that to a let instead of a const when we import it. And try that again. Cool, so now we get a 204 no content when we try and delete the user with an ID of 1. If we try and list our users out, that user with the ID of 1 is now gone. Yep, good catch, Fraud. That should be user, not users. I typed that out so quick I made a lot of mistakes. I'm glad you guys got my back. Yeah, it still worked. If you tried to delete a user that didn't exist, it probably would have errored. But now if we try and delete a user that doesn't exist, try deleting a user with ID of 1 again, or make sure you restart your server and then try it. Let's try and delete a user with 5, ID of 5. We should get a 404. Nice. Don't worry too much about these functions that are simulating a database, like this filter function, the find by index. Don't worry about that too much, because from here on out, you're going to be using a real database. So you're going to have some database functions from like another file that you import that allows you to do all this stuff: updating user, finding user by ID, deleting user. So we're only doing this for now just because we don't have a real database to work with yet. And it's also a good reminder as to how to use these array functions, which are really handy. Okay, what is res.params.id? Why params? Request.params.id. So that comes from the URL. So in this case, if someone goes to /users/some ID, the value of that ID is going to get saved in the variable of request.params.id. Okay, it allows our endpoints to be kind of dynamic, right? We're not hard coding an ID, but we're saying an ID should be here, get the value and put it in a variable. All right. We're a little over on time, but that's all right. Are there any last minute questions related to what we just did with this put and delete request? Where was let used? Right at the top. When we imported users, we changed it from a const to let because we're changing that variable. Okay, using triple equals instead of double equals. In this case, we have to use double equals instead of triple, because if you look at the users file, the IDs are numbers. They're not strings, they're numbers. And the parameters that come from our URL are always going to be a string. So we have to do kind of a less strict equality check. If we wanted to use a triple equals, we would just have to convert that ID to a string as such. But in this case, it's just easier to do a double equals. I'll leave that one up to you. Explain a bit how request and response operate behind the scenes. you're gonna have to figure that one out on your own. Go read the Node HTTP documentation and figure out what requests and response, what those parameters are actually doing, and all the methods that they have available on them. I think that would be really helpful if you want to delve more into that. It's all in the Node documentation. All right. Well, that's it for tonight. Thanks for sticking with it, even though we went about 8 minutes over. Hopefully this was a good introduction to backend. I hope it got you excited to learn a little bit more. I know it was a lot to take in on the first night, but I promise this will start to make more sense as we move along. This is just JavaScript. Keep in mind, this isn't any special language. It's just JavaScript. So a lot of this should be a good reminder, a good refresher on some of these functions, some of this functionality of how to write the actual syntax of JavaScript. So take it slow, let it sink in, take your time, and just don't stress too much about it. We're going to be doing this a lot, so you'll get a lot of practice. On Thursday, we're going to dive deeper into routing and kind of some of the architecture that we're using here. Let me give you a link for your project tonight. So your project, notice that all of the database functions, so in the project, in our guided project, we kind of just baked that database. We did a lot of weird like array functions and filter and find. But in your project, you actually have a database file that does all that for you. Okay, if you look in data/db in the project, you'll see that there's these functions find by ID, insert, update, remove, that do all of that for you. You just have to import this DB file and call these functions with the proper parameters. Okay, each one of them returns a promise. That's important to know. So when you actually call these functions in your route handlers, you're gonna have to use the .then, .catch syntax or async await. If you know how to do async await, we'll talk about that later if you don't. So essentially in your endpoints, instead of calling like users.find in this case, you're gonna call users.find by ID, and you just pass the ID. And it's gonna do it for you behind the scenes. And then you do like .then, you'd have a callback there, which is where you called res.json and so on and so forth. Okay. All right, we'll have fun with it. And I'll see everyone on Thursday.